Hello everyone, my name is Stanley, and today we're going to be talking about statistics. So what is statistical variability? To answer that, we have to know what statistical questions are. So a statistical question is a question that anticipates variability in the data related to the question and accounts for it in the answers. Basically, what this means is that there is not just one answer to the problem, but there could be multiple. Let's look at some examples. So first one, how many cars does a typical family have? You can't just answer that with a single number. Some families may have 2 cars. Others may only have 1. Some may even have 0. But there is no one right answer to this question, which is why it is considered a statistical question. And let's look at the second one. How much does a computer cost? Again, there is not just one right answer to the problem. Some computers may cost $500, others $1,000. Others even $2,000. There can be multiple answers, and the answers to the problem are varied, meaning they differ. Let's look at some examples that are not statistical questions. How many days are in January? Well, there is a set number of days. There are only 31 days in January. There is no other answer other than 31. The answers to the problem are not varied. There's only one answer. Let's look at the second one. What year did Abraham Lincoln become president? Again, there's only one answer to that, 1861. There are no other answers to the problem except for the correct answer. So, therefore, both of these examples are not statistical questions. In statistics, it's extremely important that the data that you're collecting in whatever you're doing, like an experiment or a survey, the data must be representative, and that's what we call representative data. Basically, the people that you're polling or surveying or choosing must represent the entire group that your experiment is dealing with. The entire group, that's what's called the population. In more formal terms, it's the entire pool from which a statistical sample is drawn. It can refer to an entire group of people, objects, events, hospital visits, or even measurements. It is basically just a set of similar items, people, or events which is of interest for some question or experiment. For example, if your experiment is dealing with 11th graders, then the population is all 11th graders. Let's say you were surveying people in the United States. Everyone in the United States would therefore be the population. But your experiment or survey can't include everyone in the population. It's just not practical. So that's why we usually deal with a subset of the entire population, or a sample. So your sample must be representative of the entire population, meaning the people, things, or events must represent that entire population in order to have a valid experiment. So how do we make it so that it does represent the entire population? Well, that's where random sampling comes in. It's best to have a sample that is chosen at random so that it accurately reflects what the population is. In order to get a random sampling, all people or items have an equal chance of being chosen. There is not one person who is more likely to be chosen than another. Everyone has an equal chance of being involved in the study or experiment, so therefore it can accurately represent the population. In the picture here, it's just an example called systemic sampling, and that's just a procedure in which you choose every somethingth person. In this example, it's every third person. So you would choose this one, and then 2 people later you choose it again, 2 people later you choose it again, 2 people you choose it again, 2 people, and you finally choose it again. And in these people that are chosen accurately represent the population. Let's look at another example. Let's say you had a bag, and in it were all different types of cookies. There are red ones, blue ones, yellow ones, green ones, purple ones, you name it. And let's say you take one from the bag without looking, and let's say you chose 15 cookies out of 100 total cookies in the bag. That would also be random sampling, because you don't know what things you are choosing. That 15 cookies that you chose at random would accurately represent the entire population. However, when some people or items are more likely to be chosen than others, then the data is not representative of the entire population, and that's what we called a biased sample. For example, let's look at the picture here. The population has 8 more females than males, but in the sample, you only have 4 females with 4 males. So in your sample, you have 50% female and 50% male, while in the population, it has 75% female and 25% male. Obviously, the sample does not reflect the population. In scenarios with such small numbers, random sampling may not be as effective. However, with much bigger numbers, random sampling would yield a sample that would really accurately represent the population. Another example of a biased sample is, let's say you want to know how many people watch sports at home. Let's say our population is every New Yorker. And let's say you go to a sports stadium and choose some people there. So obviously, they are more likely to watch sports at home, given the fact that they went to a sports stadium. So things like that would make your sample biased. In order to make it not biased, let's say we wanted to go with the same experiment, where you wanted to know if people watched sports at home. So instead of going to a sports stadium in New York, let's say instead we go to a supermarket in New York to see if people watch sports at home. So choosing people at random from a supermarket will more accurately represent every New Yorker, because the location does not have a bias toward the question that you're asking, unlike at the sports stadium. So I'm going to end the video here. Make sure to check out any of my other videos relating to this topic if you want to learn more. There are some questions that you can try for classwork and homework in the links of the description. Thank you all for listening, and I'll see you in the next one. Bye!